figure out how it works, and you came along and started contributing. It's really great. But also, Potuz has been part of the CDAP of the EPF before we took over with Josh under Piper. So the OG EPF fellow as well. So it's an honor to have you here because with your current work on the ePBS on Prysm client, I'm sure fellows can learn a lot from you and your journey. I believe you have some sort of presentation for us, something to talk about at first.
Oh, so actually, I don't really know how you guys want to run this. I have slides for a talk that I thought might be interesting here, which is this exact same talk that I gave at Flashbots to pitch ePBS. I mean, there's enough slides to cover like a 3-hour talk. So it doesn't really matter how.
Yeah.
I mean, this is also supposed to be an AMA, so I'm not really sure. I mean, if people are really shameless and they actually want to interrupt me like every 30 seconds, then I can go with the slides, and that's something I would love. If I get interrupted every 30 seconds, then I can just start and try to aim to give this the full talk. If people are just quiet, then probably it's better if I only speak for like 10 to 15 minutes and go over just the first few slides. I would much rather be interrupted all the time, and then we can have a conversation, and then we can just decide over as things go by how this meeting is going to evolve.
You guys are shameless. Yeah. People already love you. That's great. Yeah, we love you, Potuz. I mean, that's Potuz is a very candid person. That's why I love to have you here and just to deal with the openness. I think you can just start the slides, the presentation, and people will either interrupt or you can just let's give it like 15 minutes or something at least for you to give them the context of the presentation, and then we will have more room for the AMA. And I would say like yeah, if people have some questions along the way, like feel free to raise your hand and you can
All right.
speak. But yeah, feel free to share the slides. Go ahead and
So let me see if I can do a window instead of, yeah, so I can do a window.
yeah.
Let me know if you
Awesome.
can guys see this.
Perfect. Yep, we see
Okay,
exactly.
good.
Yeah.
Because I don't have the mirror in here. All right, so I timed it correctly, or Mario timed this correctly. The EIP is out, or at least the PR is open. I'm linking it on the chat. And there's a link there for the actual changes that are in the consensus spec. That's a different PR, which I will link now in the consensus spec. All right, so I'll go over like in the first few minutes. If I get a lot of interruptions, then we can just go over most of the slides. But if no one speaks at all, I'm just gonna stop in an awkward position and force you guys to ask questions. And since this is supposed to be an AMA, the questions that if you interrupt me, you can interrupt me and ask me about something completely different. I don't know, vertex address if you want. Anyways, so I want to tell you about ePBS, which is the project that I've been working on for over a year now. I haven't really done any Prysm work in a long time now, and I've been focusing on ePBS. And I don't want to get into the philosophy of ePBS. If you want to ask me about that, I'm happy to answer. I'm just going to go over the mechanics of ePBS, which is something that I want to sell. So instead of telling you about ePBS, let me tell you how the Ethereum slot works today. I'm not really sure how familiar everyone here is, so I'm going to try to go slowly here. The consensus algorithm we have today in Ethereum works as follows. Slot is a unit of time, which is 12 seconds. And at the beginning of the slot, this is how things should work. At the beginning of the slot, the proposer builds a block and broadcasts it. But proposers mostly do not build their own block. They outsource the construction of the payload of the block, the actual transactions on the block, in exchange for money, in exchange for ETH as a form of payment. They gather the bits at the beginning of the slot, and they delay this as much as possible, because the longest you delay the broadcasting of your block, the more money that you can get from the builder that is extracting MEV during that time. So typically a block would arrive to your node 2 seconds into the slot, and it needs to be validated and attested before 4 seconds into the slot. So that means that your node is doing most of the work in those 2 seconds between the block is arriving and the attester is, well, it has validated it, and the attestation goes out at 4 seconds. The rest of the slot is sort of like irrelevant for the rest of the conversation. The next proposer has about 8 seconds or about 10 seconds to validate the payload before proposing a block on top of this or not. But the attesters are the hot path. The vast majority of validators only have 2 seconds to validate a block. Okay, so this is just a text over the last slide. We have 2 seconds for payload validation. We have 4 seconds for attestation propagation. After those 4 seconds, those attestations are aggregated. This is a feature of our consensus algorithm of the moving to proof of stake. And then we have the last 4 seconds into the slot where those aggregated attestations are propagated, everyone gathers them, and you compute your new head. And the question is, can we make the hot path better? Can we make it so that you have more time to validate? In principle, we could. We could, for example, ask the validators not to submit their attestations 4 seconds into the slot. And you could say, why don't we attest at 6 seconds into the slot? Because the remainder of the slot is wasted time on the CPU anyways. But if we did that, what would happen is that the proposer would send their block not at 2 seconds, they would send it at 4, at 5 seconds. Because the longer they wait to submit their block, the more MEV they extract. So that's an inherent problem of the current mechanism for PBS that we do not have a solution for. So this is how enshrining PBS would work. You would gather the same way bits at the beginning of the slot. You would still delay as much as possible to submit your block. So the proposer would still submit their block as late as possible. In this example, it's 2 seconds. It could be more, it could be less. And the validators would have to attest to that block at 3 seconds. So it looks worse, actually, than before. Before they needed to attest at 4. Halfway through the slot, the actual payload would be revealed. So the consensus block that is being broadcast at 2 seconds will not have transactions, will only have a commitment to a builder to submit later those transactions. And then 9 seconds into the slot, a new committee would vote for whether or not they had seen the payload. And what we want to do is to implement an auction mechanism so that the proposer can sell the rights to a builder to submit their block without trusting it. And the builder can actually buy those rights without trusting the proposer and knowing that they don't need to reveal their payload unless they know that that payload will be canonical. So here's how the slot hot path is now going to work. You still have a very hot path for consensus layer validation. Since the block arrives until the block is actually attested, the validators, which is the attesters, which is the vast majority of validators, will need to do hard and fast computation. But that computation is very fast because there's no execution now. It's only validating the state transition on the consensus layer. That typically takes 80 milliseconds on a normal computer today, as opposed to the 1 to 2 seconds that takes to actually execute the block. Kira, you can speak up. I'm not even reading the chat.
Yeah, hello.
Actually ask the question.
Can you hear me?
Yeah.
Yeah, I was asking why did we reduce the CL validation time?
Oh, so because the CL validation time is actually very fast. So we can sync a block. If we don't care about execution, we can sync a block very, very fast. This is pre-merge time. We were talking about 70 milliseconds per block. After merge, now it's a little bit more, but still is under 100 milliseconds to sync a block.
Okay.
Don't raise your hand, guys. Just speak up. We're a civilized group. Someone said, I got a notification that someone wanted to speak up. Who's this? Risha.
Audible? Am I audible?
Yeah.
Yeah. So my question is, you mentioned in one of your blogs and said here also that commitment to a particular builder is needed, not to a particular payload. So would you like to clarify on this? Why only a builder is needed to be committed?
Yes, so that's a very good question, and I have that at about like slide like 20 something, and we're in the second slide. But yes, so here I haven't been specific enough in the way that I'm talking today. Is actually the way that the EIP is phrased, which is what it's called as a block auction and not a slot auction. So here, this consensus block actually does commit to a particular block hash, to a particular payload, and that payload is checked that the builder is submitting later. But that's not really necessary. You could have a different, it's going to have a different market dynamics, but the builder could say, I am willing to pay this much, send a signed message like that, and not specify what is the payload that they need to reveal. Only specify that they will be the ones that are allowed to reveal a payload during that slot. So that's what is known as a slot auction. And the difference, there's many differences, there's subtleties too. One advantage, for example, would be that between the time that the bid is accepted and the time that the payload is sent, this is dead time if you commit it to a particular block hash. Because during that time, no builder can actually be building anything, because the builder that bought the right already has committed to a particular payload. He cannot be updating it. We already know that that payload exists somewhere and is waiting to be released. If you only sold the slot, then between these 2 seconds and the 6 seconds, that builder would still be able to construct on his payload. On the other hand, that also lends itself to a timing game in which that builder is now enticed to send the payload as late as possible, because he already knows that he's the only one building it. And the longer he builds, the more MEV he can extract. That's one of the things. Another thing that can happen is that the builder can attack the network. Since he hasn't committed to a particular block hash, he may send 2 separate block hash, both of them valid, both payloads valid, in order to split the view of the chain. And we need to deal with those 4 choice situations when we analyze the security of the system. Did this answer your question somewhat?
Yeah, I partially understood. Maybe when it is completed, I'll get it more clearly.
Okay.
Yeah.
But essentially, the big difference here is when the consensus proposer submits a block, he's submitting a commitment. And this commitment can have different flavors. One of them is, I sold my rights to builder number 3 to submit a payload with this particular payload hash. And then later in the 6 seconds, the remainder of validators would actually check that the builder number 3 submitted a payload with that particular block hash. Commit to the block hash. We could have a separate auction in a different mechanism where the proposer submits a payload, a block saying, I am committed to receiving this much ETH from builder number 3. As long as 1 valid payload from builder number 3 shows up, that payload is good. And there are different dynamics for this, and it's a trade-off of design. I suspect that EF research likes better slot auctions than block auctions. I personally haven't thought much about slot auctions. I also believe that they're better, but I'm not really sure. At any ways, the big difference on this mechanism is that the hot path no longer involves validating the payload, which is the hard thing on Ethereum. Validating the payload can be of the order of seconds. A typical Raspberry Pi could take 4 seconds to validate a long payload today.
Question about that, if I may.
Yeah. Yeah, someone.
So we're reducing. Can you hear me?
Yeah.
We are reducing validation time or a tester time from 4 to to 3 seconds. And granted, the payload is much more less sophisticated, so it consumes less calculation. Is anything changing in the payment of the attester, because they are currently being paid at 4 seconds?
Not at all. I know attesters are not being paid at 4 seconds. Attesters are being paid when you perform the epoch transition action. Attestations are not being paid immediately. They are paid on the next epoch when you count whether they attested or not. And no, nothing changes in that regard. Yeah.
Isn't it connected to attesting before 4 seconds? Okay.
Well, actually, it's not connected to attesting before 4 seconds either. It's not that today. Attesters are required to attest before 4 seconds, but this is not enforced by the protocol. You can send your attestations 3 minutes late, and it will still get in a block today, and you will still be paid. You will be paid less because you will most probably lose the head vote, but you will still be paid. There's no place in this protocol where we enforce those 4 seconds. And in fact, if you send your attestations
maximum
to later,
payment.
Yeah, you still get maximum payment probably if you send at 6 seconds. So today, if you hack your node and you send your attestations to 6 seconds instead of 4, you will probably perform better than the vanilla validator. There's no enforcement of these 4 seconds.
Okay, thank you.
All right. The big win here and the huge win here is that, well, we attested to the block at 3 seconds for choice, and the head of the Mario has a question. It depends on inclusion distance. Yes. So, okay. So let me explain how payments to attesters work today. You attest, and when a validator sends an attestation, it's attesting to 3 different things. It's attesting to what was the last justified block that they have in their view of the chain. That's what is called the source. They are attesting to what is the current target epoch. So that is what they see as the first block in the current epoch, or if there wasn't any block in that one, the previous to that. So that's called as the target. And then there's the last one, which is what is the current head of the chain, which in this case of this slide, that would be the block root of the block that was just revealed. And attesters get different amounts on whether they get either of these votes correct, and also whether they get them timely. And timeliness is measured from the time that they were supposed to be attesting, but only the slot, not the actual wall clock, the slot that they were supposed to be attesting, and the slot in which their attestation got included in a block. So it's irrelevant, these 4 seconds, 6 seconds, or 12 seconds, or whatever it is. The only thing that matters is which proposer, after they sent the attestations, included that attestation. So if the next proposer includes your attestation, it doesn't matter if you attested like at 11.5 seconds. It only matters that the next proposer included your attestation.
Got it. Thank you for elaborating. Yeah, the docs that I shared have a good visualization of how the reward curve goes down with the delay. So
So inclusion delay, attestation delay is something that existed in phase 0, and now we measure it in a different way. We have flags to check timeliness on these 3 different things. But the original algorithm from phase 0 to the Altair fork only counted this inclusion distance. All right. So going back to ePBS and what is the scaling of ePBS that brings to Ethereum is that now, when the payload is revealed at 6 seconds, no one needs to validate it immediately. No single validator needs to validate it in less than 2 seconds. So the next proposer, of course, needs to validate it, and it will have 6 seconds to validate it before he proposes his block, because it's going to be based on this payload. But the next attesters, which is the vast majority of validators, they have 9 full seconds to validate it now, instead of just 2. right? So there's no validation done on the payload until the next block is revealed, and by then you need to know that the previous payload was valid. So this is the big win. If we could solve state bloat, for example, database growth, or if we had stateless nodes, then we could send huge blocks, because this gives us 9 seconds to validate them instead of just 2. So if we solve the problem of the state growth on disk, then ePBS already gives us a solution for execution validation. Well, this was a talk for Flashbot, so I guess you guys don't care much about like how the building mechanism change and the searching mechanism change for MEV, but those two things also are going to change under ePBS. All right, so this is a summary of those slides. We have 9 seconds for payload validation, 2 seconds for the consensus layer validation, but the consensus layer validation is very trivial. You wouldn't need to validate much. Also, it's much faster to send the block because the block is very tiny now. It doesn't have all the transactions. The CPU usage is distributed throughout the slot instead of like having the node work in just 2 seconds and then doing nothing the remainder of the slot. Now you're working 2 seconds hard to validate the consensus block, and then you're working after the payload as long or as fast as you want, but it's throughout the remainder of the slot to validate the payload. Builders actually, yeah.
So if builder is not having any commitment and like he does not send the block at all, does the slot go empty, or like is the proposal slashed?
In order for a proposer to propose a valid block, they need to include one commitment. A valid block includes a commitment. The way a vanilla validator would work is exactly as today. At the beginning of the slot, you request your execution layer to give you a block, and you request from the builder to give you bid. Okay. If no builder pays as much as you want, then you will take your own block and include a bid to yourself.
Okay.
So the vanilla validator would still be able to produce a block itself, and it would produce a bid to itself and immediately broadcast the block because they already know that they won the auction.
Okay.
And in fact, trusted builders, so builders that already trust the validator or that immediately see the block and count attestations for it, because, for example, you're a Lido validator and you know that you're a Lido builder as well, you know that Lido validators are attesting to your block, then you can just immediately broadcast your block. You don't need to wait for 6 seconds. In fact, fast builders will do this immediately. Fast builders will count attestations, reach a threshold. You can reach a threshold today. In less than 1 second, you can count all possible attestations on the network. So in less than 1 second, you counted that you've seen every attestation for the block. You know that that block is strong. You can just submit broadcast your payload because you know that you're safe. Okay, so what are the guarantees that ePBS wants to have? So this is an auction. This is the proposer is trying to sell the rights to build on this block, and the builder is trying to buy those. So what are the guarantees that you want to ensure so that this is a trustless interaction? One of them is that no matter what the builder does, the builder already gave you a bid, to a signed bid saying, I want to pay this much to build a block. If the proposer includes this block in an honest fashion and sends this block, then the proposer should be paid, no matter what the builder does. If the builder doesn't reveal the block, if the builder reveals a different block, if the builder reveals an invalid payload, whatever the builder does, these proposers should get its payment. And this is enforced in a very simple way. The builder is a validator. We request that builders are validators, and whatever bid is included on the consensus block, part of the state transition on the consensus layer is take this money from the builder, transfer it to the proposer. That's it. You do it immediately. So the proposer gets his payment upfront, even before the builder has even revealed the payment. All right, so this is a contentious point for many people. Will builders want to be staked? Will builders want to avoid using ePBS because they don't want to be staked or not? There are many answers to that question. One of them is I talked to the main builders and they told me that personally, they don't care, they will be staked. That's one possible answer. Another answer is the following. We do not know how to provide builders with a trustless way of paying that does not require them to have the money up front. If we didn't transfer the money on the consensus layer, like the mechanism I just described, and we wanted to do this on the execution layer, let's try to imagine how that would work in a trustless manner, right? So this would work as follows. You send the money as it is today in a transaction to the proposer, and that transaction is executed on the execution layer. Now, how does the proposer know that he has a transaction that is going to pay him? And he needs to know this in advance to be in a trustless manner. The only way that we know how to implement this is that the builder gives the proposer, together with the bid, that transaction. And it gives it the transaction saying, here's a transaction that pays you. You can execute it now. It's a signed transaction. If you execute it now, you're going to check that this transaction is valid and you can be paid. But that means that that transaction has to be the very first transaction of the block. It cannot be the last transaction of the block. It means that we do not know how to make the builder to get money out of the block that he's proposing, for example, by extracting MEV, getting enough money, and then from that money, take money to pay the proposal. This is impossible to do today. It requires some ZK magic that we do not know how to do. So that's another argument for staking. The solution we have on the L is not better. It's just exactly the same for them. They need to have the money up front. And the actual answer is that MEV is very highly concentrated in a few blocks. Most blocks come without any MEV. Just in a few blocks is where the actual money is made. There's an NFT drop, there's an airdrop, there's some run to buy or sell something. And in those very spiked gas auctions on chain, the builders or the searchers are making the biggest money by front running. So when this happens, if you have a particular percentage of validators that are not willing to run a modified node, today we have at least 10% of validators that aren't really willing to run with builders. There's much larger set of validators that are not willing to change their software. So then the builders, by not staking, are going to be risking not producing those blocks whenever they fall on such a validator. All right, so this is a good point because it's already half a talk and I can stop there. The remainder of the slides are going to talk about like the safety concerns, like what are the guarantees for the builders, what are the guarantees for the proposers, what are the market mechanisms, and then later for those nerds like me, we can talk about forgeries. What are the attacks, what are sandwich attacks, what are ex-ante attacks, what are post-ante attacks, and what are the safety mechanisms for those. But this is a good spot to stop and see if there's questions. I see that there's one question on this chat, which is, the ePBS have constraint on the bids? Like builders can only bid up to a certain point, etc. Yes. If in the proposed DIP, where the builders are staked and you need to enforce that the builder can pay. So if the builder is staked 10,000 ETH, the builder can bid up to 10,000 ETH because the payment is extracted from the consensus layer. If we go with the mechanism that allows the builder to pay in a transaction upfront, then there's no bound as long as the builder has that balance in the execution layer to pay for it. I hope that answers that question. Are there any more questions? Do you guys want to talk about something else?
Yeah.
Or should I continue with this?
I have a question.
Yes.
Can the proposer and builder still bypass ePBS, like do it off chain? Or
Yeah, this is the problem that ePBS solves is the following very basic problem. If I am a proposer today and I want to sell my rights to build a block, in a completely trustless manner, I do not know how to do this. I don't have an option to do it. So the problem that ePBS solves is it gives the proposer a way of doing that. It doesn't force the proposer away. We don't need to force proposers to behave in a way. If proposers are not rational or they want to bypass the protocol because they feel like they trust whatever builder or relay is out there, that's absolutely fine. In fact, I think you can prove it as a theorem that there's no mechanism that would force proposer not to trust a player. Another comment to that is that it's actually kind of irrelevant if proposers bypass the mechanism. On the one hand, it's irrelevant because most of the gains come from the pipelining on execution. So even if the proposer actually do bypass this mechanism, we get a lot from just the fact that we're delaying the validation of execution. Another comment to that is that it's very hard to believe the way the auction is tailored is such that it's beneficial for proposers not to bypass it. And for builders, it's not so clear. So this change makes the auction much more proposer friendly than the current auction. Currently, the builders are cartelized in three relays. There are the relay doesn't really pay the best bid to the proposer. The relay gathers bids and they take the difference between the first bid and the second bid, and they pay the proposer the second bid. And from the difference between the first bid and the second bid, they spread this between the builder and the relay. So that's already one thing. The other thing is that the proposer can hide the bid under ePBS. The proposer can request bids from the builder and may hide them or may advertise them to every other builder however they want. It's their choice. For builders, the situation is actually more complicated because builders currently can see the bids from other builders by polling the relay. In this mechanism, builders are not gated by a relay. So if you're a builder, you don't need to have an authorization from the relay to submit payloads. You can just open your endpoint and proposer will request it from you. And you lose this extra timing between you sending the bid to the relay and the proposer requesting that bid from the relay. The proposer would request it directly from the builder at the exact time that they are about to propose. So all this extra delay makes it much more expensive for a builder to be working with an intermediary. So even for builders, it's cheaper for them and it's better for them to just open an endpoint and work themselves as a relay. I'm not sure if this answers your question, but there was someone that, yes.
Can you hear me?
Yeah.
Okay, I have I don't know much about ePBS, but I have a fundamental question and a little bit of confusion in how the reward system works. So you're saying that the builder is staked and the reward that comes out of the actual build block would be a transaction, right, in the block itself? And
no.
Okay.
No. So you mean the reward for the proposer?
Mm-hmm.
No. So in the situation where the builder is staked, so what I was discussing is two different ways of implementing the payment. One way is the simplest way, which is the builder is staked, and then the payment is carried in the consensus layer. So you take money out of the validator, which is the builder, and you give it to a different validator, which is the proposer.
Okay.
No transaction is involved here.
Okay.
Then another way of implementing this would be by a transaction, but then you don't even need the builder to be staked at all. So in that world, the builder is not even staked. The builder just is someone that has a public key and a private key that we identify, and that's it. And then the builder sends a bid with a transaction. And that transaction pays the proposer on the execution layer. So that would be an alternative mechanism that has some advantages. For example, for the builder, it doesn't need to be staked, it doesn't need to be running the validator, but most importantly, it doesn't need to be draining money on the consensus side. The current mechanism, imagine if you're a builder and you're winning a lot of blocks, like say you're Beaver builder or Titan builder, or any of the major builders. Your validator would constantly be losing money because the money goes as payments to other proposers for the bids, and then you are getting money on the execution layer by MEV extraction. So you're making money on the EL and spending money on the CL. So from time to time, your builder will need to make deposits to top up their builder, their validator on the CL. So that's a disadvantage of the system that I'm proposing today. It's an obvious disadvantage, but it makes the system much easier. It's a fork that is only a fork on the CL side, and it doesn't need changes on the consensus layer, on the execution layer. The other mechanism would allow builders to not need to make deposits because they will be paying on the execution layer and getting their MEV extraction on the execution layer. And the cost of doing that is that, well, it will require changes in the consensus layer, in the execution layer. It will be a joint hard fork, which is much harder to actually implement, to test, and to roll out. And also it requires the validators to execute something when they import the consensus block. They need to execute at least the payment transaction.
Makes sense.
And Potuz, using the alternative with a transaction, wouldn't it be more, I mean, less safe? I don't know, in the context of account abstraction, couldn't those transactions be used as an attack?
No, so that's why we do not know how to do this unless the transaction is just the very first in the transaction, in the very first block. Yeah. You send the transaction, and then the proposer sends their consensus block together with this transaction. So nodes immediately executed, and this is the new execution state. So the actual payload needs to build on top of that state. So it is absolutely safe. It's just more complicated to implement. I see some questions in the chat. I suppose that this was already answered, but just mentioning. Yes, the easiest we can do is not to change any of the consensus side on that regard. So if the builder drops from below 16 ETH, it goes out. This also precludes builders from being staked less than 16 ETH. So it makes it harder for a builder because they need to have at least 16 ETH. We do not have a mechanism to have builders being staked with less than 16 ETH because that would open for spamming the consensus layer.
I have a question for Potuz. I have a question for Potuz because I think this is a really good one and really fun one. And something I like about ePBS is that currently the block market is really weird, right? Because say if you have a very valuable block, right? As a builder, I may not want to add any block sidecar to it because it's gonna prolong the delay of the block, and then the block could get reordered, right? So how does that change for ePBS such that for the incentive to release a block sidecar?
In that sense, I don't. So I know what the answer that you're expecting for me to get, and I'll give the answer that you're expecting me just to mention. On the other hand, from the market mechanism, I'm not really sure that this is a deep change. So today we're aware of only one thing that is affecting builders on the blob market. And this thing is that if you include more blobs in a transaction, in a block, then that block becomes heavier. It becomes heavier to validate, and it becomes heavier to propagate. And it makes your block more likely to be reordered. So then there's two things that are in contentions here. You are, on the one hand, a rational actor wants to delay the revealing of their block the most, and they want to delay it because they can still extract MEV up to the very last millisecond. And they also want to delay it. For example, they may want to delay it to obscure information that allows them to be constructing the next block while other builders do not. So there's many different reasons why you might want to delay your block as much as possible, and those reasons might still be there on ePBS. But the situation today is that because you want to delay your block the maximum possible, you cannot include many blocks because you cannot delay much and include blocks at the same time because you're going to be reorged. What ePBS allows you is that if you see a commitment to your block, even though if you haven't seen any attestations for that block, you know that the commitment is already there, then you know that you can broadcast the blocks very early. Even before your payload, you can broadcast the blobs immediately. And that gives the blobs 3 more seconds to propagate and to be validated than your own payload. So in principle, that takes away this disadvantage of including blobs. But on the other hand, you still want to delay your block as much as possible because of what I said. Even if you are not going to be reorged because of the guarantees of ePBS, and you're not going to be extracting more MEV because you're already committed to a payload, for example, you know that you're not going to be extracting more MEV, you have the information that this block has this state transition function. So you can already be constructing the next block and beat the other builders by not revealing your block on time. So these timing games are always going to be there, and it's going to take some time for us to actually understand them all. I'm sure builders are going to know these games before we do. But it does seem like the blob market will get better on ePBS. Oh, Kira, that's a great question. Sensor resistance. What I've described today does not have any implications at all for sensor resistance, except the following. So I'm not talking about any inclusion list nor anything now, which is perhaps what you wanted to hear, but already ePBS without anything does help in sensor resistance in the following way. If I am a proposer today and I want to connect to a non-censoring builder, what can I do? Well, there isn't a relay that only includes blocks from non-censoring builders. The major relays, they include blocks from both censoring and non-censoring builders. That means that if you request a block from a relay, even if you only want to take blocks from non-censoring builders, you don't get that guarantee. Because if the censoring builder has won the auction in the relay, you're going to get it from that censoring builder. So a proposer today cannot choose the builder. A proposer today can only choose the relay. Of course, we can socially enforce this by having a relay that only includes non-censoring builders. But this doesn't exist today. And if it did, it would be in a trusted way. Even in a trusted way, at least ePBS makes it easier. It makes it so that the proposer can get a list of builders that they themselves advertise as non-censoring, and you only contact those builders, and that's it. Now, which is your actual question, like, can we do something about sensor resistance? Yes, we can. The current version of ePBS is compatible with EIP 7547, which was a proposal for inclusion list that did not make it into this fork, but might make it into the next one. There are alternatives that are being researched today. Inclusion list is one way of dealing with sensor resistance shit. In particular, forced inclusion lists. Those are inclusion lists that will not allow any payload unless the payload includes those transactions. And yes, there are mechanisms to deal with those. Their reason 7547 did not get included was account abstractions and some edge cases that we found shortly before this EIP was scheduled to be included in the fork. And ePBS makes those issues slightly better, but it doesn't solve them completely, but at least it solves the fork choice part of them. But today we're researching into different alternatives. There's fork choice enforced inclusion lists that seem to be, they are based in a committee instead of a proposer deciding the censoring transactions. And those approaches seem to be better. Research is new, so it's not really clear. There's a question by Jorge, I assume, or Georgie. Could you speak it up?
Sure.
In slot auction, since a builder has monopoly after they win the slot, the MEV found after the auction can't be burned or paid to validators. Why is this preferred to block auctions where they have to specify the block?
Oh, okay. So, yeah. So there are several iterations on top of block auction on top of ePBS. With block auctions, we can go to slot auctions, and then we can go to execution tickets, or we can actually do the full separation between the attester and the proposer, which is the one of the latest goals of the research on that field. I would encourage you to have a conversation with Rick about this instead of me. I have strong opinions on the matters, but it's their field of research, which is I think they're more qualified to answer those kind of questions. But there's a trade-off. There's a trade-off. You can burn that MEV if you make the auction very far in advance. Then in theory, what's going to happen, that's what the theory said, that if you make the auction very far in advance, like 32 slots in advance, as execution tickets wanted to do, then the buyers would be buying on the average price of MEV. It's going to be smoothened out. And then what you burn is that the fee of the buying of those tickets. On the other hand, there's this argument that the risk price, that you need to discount the risk because of this time in advance that you're paying for the ticket, then that is not being captured by the protocol. Yes, so I think these kind of questions that are market related, I'm not the right person to be asked those questions, and I would ask these questions to the RIG crowd. I'm more interested in the safety concerns and the trusted assumptions of the current protocol than the market assumptions of the current protocol.
Thanks.
There's one thing that is worse, I think, than the MEV that the builder will be extracting out of a slot auction. One problem on block auction is the UX of this. If I send a transaction after the auction has happened, then my transaction cannot make it into the current block because the payload was already committed. So this transaction can only be checked, even to be checked that it's going to be valid. You can only check it in the next block. So from the point of view of the EL, there are some changes that are not hard fork that are going to have to be taken into account, because now the EL is going to be propagating transactions that might actually be invalid once the already committed payload makes it on chain. So ePBS in this sense might lend itself to some spamming in the network. We need to analyze that. So these are the kind of questions that I'm more interested in about, like safety concerns of the protocol. We have like 5 more minutes. I think this was scheduled for 1 hour. I don't know. So we can.
Are there any like new projects, if any of the EPF fellows want to contribute to ePBS in general, like besides Prysm code, like what are some other like useful things you think people can help on?
I've heard from one fellow here, I think Dan, who's working on delegation that has some tangential connection with ePBS. I think fellows would be welcome to work on the Builder API. Yeah, so delegation seems like a cool project, more connected directly to ePBS. I think working on the Builder Connect, the new Builder API, would be good. Understanding what will be the dynamics on an ePBS world, on how builders connect to open sourcing, for example, the relay code would be great. So that is a neat project. Flashbots has a relay today. Open sourcing it and making it fast so that any builder can actually open an HTTP point, having the design for a contract so that on-chain proposers can find which builders are and what are their addresses that the builders are advertising their payloads. That's a really cool project, so that you don't need to gate builders by, say, ETH Research or ETH Staker posting lists of builders. You can just have a contract, and anyone can submit to that contract their address. I am sending bits in this address. So that's a cool project. You can contact me, and I have a bunch of projects that I think are cool to code, and where none of us is working on any of those. Those are like future iterations of over ePBS.
One good one on top of my
One
mind is the
question, if
current four
possible.
choice. Sorry, go ahead. Oh yeah, so I was gonna say one good one on top of my mind is that current like four choice is very complicated. It's probably the hardest part of ePBS. I think writing like iteration of like four choice spec tests will be very valuable. That kind of force you to understand how four choice works. But then also like write Python code to generate spec tests, which I'm really happy to help someone with it. But yeah, I really want to get that done.
That will be helpful for APS also, no?
There's a I wouldn't want to get it's true. I wouldn't want to get too far ahead, but yeah, we need spec tests. We do need spec tests, and we haven't generated them. It would be cool to have them.
There's no time probably to talk more on builder safety concerns. So if I may have one question on it, final.
Sure. I'm here until Mario kicks me out, so it's fine.
Okay, so builder builder needs to see. I'm paraphrasing you. Builder needs to see the payload in order to be able to say, okay, I'm going to beat this round, or I'm not going to beat this round. Is this related to builder safety, or related to censoring, or being allowed to censor, to not bid if they want to censor?
No, it's not about bidding. So if I mentioned during the talk that the builder needs to see the previous payload, it's just to simply know what is the state, right? So how does a builder work?
This was in context. I'm sorry. This was in the context of inclusion lists on R&D Discord.
So that's a different thing. Okay, so this is a very different thing. For everyone that is not following that discussion, there's one of the approaches to inclusion list. There is a new proposal, is to have a committee that sends transactions or send addresses and nonces as a form of like an attestation. These are the transactions that I would want to have included in the next block. And then someone, this case would be the builder, would aggregate those inclusion lists and send an aggregate. And then the next builder needs to include these transactions, needs to satisfy this aggregate. Okay, so the problem is that in order to build the inclusion list, to say which transaction should be in the inclusion list, you definitely need to have seen the previous payload, because whatever transaction you want to have included in an inclusion list needs to be valid after the last payload that you validated, right? So these are transactions that need to be executed, therefore they have to be executable. So whomever builds the inclusion list needs to have seen the last payload and needs to have validated the last payload too, because they need to know that these transactions go after that payload. So that's a hot path that I don't want to add after ePBS, because ePBS gave me this great thing that instead of having 2 seconds to validate the payload, now I have 9, and I don't want to lose that. So that's one contentious. The other one is, well, if you made this as long as possible, the maximum would be 6 seconds, because that's as much as the next proposer has anyways. And then the problem is, okay, now you send the inclusion list at 6 seconds at the same time that the proposer is supposed to send the block. So therefore, the builder that is bidding, does the builder know what is beating him or not. So if the builder hasn't seen the inclusion list, you might be a censoring builder, then now you're forced to either censor or pay the bid without revealing your payload. So if you're a censoring builder, you will not even bid in these conditions. Not at all. Which is somehow might be good. You might think that is good. But on the other hand, it lends itself to this attack in which I am one malicious person in the committee and I send you a transaction to the builder that will look like as though you can actually get a lot of reward by front running me. So you bid a lot, but then at the same time, I send this transaction on the inclusion list that invalids that arbitrage opportunity. So the builder is in a conundrum. He either satisfies the inclusion list and has a valid payload, but he lost a lot of money because he had already bid on this arbitrage that doesn't exist anymore. Or he satisfies the arbitrage, but not the inclusion list, and therefore his payload is invalid. So these are the sort of like the tricky situations that are appearing in that design.
Right. So you say let the builder always see the content.
I think the builder needs to know before bidding, they need to know what they're bidding on. What are the constraints of the block that they're going to be building?
Got it.
Hi, Potuz.
Go ahead.
Hi, can you hear me? Okay. I was going to ask about execution tickets and creating a new protocol market for buying and selling of bids. And I have little concerns. I'm thinking the protocol is tending towards a system where it's becoming very fragmented. Don't you think on the long run it like opens up a lot of security concerns?
I'm sorry, I don't understand. So I can barely hear you. What are the security concerns on what? On the payment for execution tickets?
No. What are the security concerns on the system becoming very, very fragmented, sort of?
What system?
By the time you are separating, when I was checking the roadmap for ePBS, and it looks like further down the line, there are going to be things like execution markets for buying and selling of tickets. Proposals can go and put their rights to create blocks up for sale and stuff like that. So I don't know. I think further down the road, Ethereum is looking much more. It's looking like it's going to get much more segmented and fragmented, like being broken down into like different pieces. So I don't know.
So yeah, I'm not really sure I follow on how this fragmentation is happening. Like today, the system is really much involved today, and it involves like several moving parts that are off protocol getting together to build a block. There's the validator that is part of a large pool that is sending requests to different relays that are gathering blocks from builders, that are themselves gathering bundles of transactions from searchers, and are themselves solving a hard problem, which is the NACSAP problem of how to build these bundles, then how to collect these bundles and order them in the correct manner, and each bundle within themselves is an ordering of transactions by themselves. So there's a lot of like different parts, different moving parts that are getting together today in a very short amount of time, which is the critical time of proposing a block. If anything, the designs that we are seeing in the future make this fragmentation better distributed throughout the slot and better pipelined in a way that not only they can still happen, they can happen more efficiently, and they can happen in a trustless in-protocol manner. So I don't see how this actually decreases the security of the system. Rather, it allows players to play within the system. And it doesn't disallow the players that want to continue playing the previous manner. So whatever worked before will continue working if validators want to continue using the previous software. So our task is to provide a way that we think is safer, we think is more open, and we think that validator might want to use it just because of that. But I cannot force validators to continue using whatever was working for them before. questions?
Question regarding the project idea. So it seems people haven't reached to consensus regarding implementation details yet. And so I wonder, what do you expect from making prototype of ePBS? And if we are going to make a prototype, what do you think it should implement?
Oh, so I don't know if you were here at the beginning of today. I posted links to the EIP that is open, and this I'm gonna post them again, and the pull request to the consensus repo. There's no consensus on the community about what version of ePBS or if ePBS, or lots of questions around ePBS, mostly about MEV. I admit that there's no consensus, no broad consensus among the community. There is consensus about client devs though. CL devs, which are the only ones that are involved in this fork, will be implementing this, finding bugs on this, and iterating over this spec. I think this is safe to say that at least 3 of the major CL clients are already having people looking into, if not the 5 of them actually, have already people looking into this Python spec. They've already read it, they're vetting it. We have a bi-weekly meeting every Friday, and everyone is free to come. Terence, if you have the link to the PM repo, you can probably post it. So we are already iterating over this spec. So the implementation details, I think there's no contention here. These are the implementation details. What there's no consensus on the broad community is not about the implementation details, but rather about the protocol itself. So I'm less concerned with that. I've already did my best to try to do the politics and explaining why I think this is good. And I'm hoping that I convince enough people that they themselves can actually now do that work. I will from now on focusing on just implementing this particular form of the consensus mechanism and talking to other client devs, because we're iterating and finding small bugs like withdrawals. Should withdrawals be processed on the payload, or should they be processed on the consensus block? These kind of things, but these are really minor things.
Right. So if I'm hearing you correctly, there is no consensus across all community, but as long as client devs are agreeing on some certain set of implementation details, we are good to have that update be applied to the
Oh,
protocol.
no, not at all. That's not what I said in any form. For an EIP, the governance of Ethereum is a very complicated subject that I am not very well versed. Therefore, I try to not participate more than just giving my opinion on what I think is correct and what I think it's not. The fact that every client would implement something that does not grant it to be included at all. Take EOF and how many years has taken for it to be scheduled on a fork. EOF has been implemented by every single client but Geth for many years. So there are many aspects in which client devs might be in agreement on how to implement them, might be in agreement of having a proof of concept. We might even have a devnet for it, like Verkle has had a devnet for the last 2 years and hasn't been scheduled in a fork yet. And the community is what ultimately decides what gets included into a fork or not. All I'm saying is that if client devs will now start iterating on a particular design, it would be this design. There's no other, and this is a very simple answer because there's no other design out there. It's not that I've seen, that anyone has seen any Python specification for any other proposal but this proposal. So if clients want to start implementing something, this is the only thing that they can actually implement because it's the only one that has been specified.
Gotcha. That clears my mind a lot. Actually, I'm interested in participating the prototyping ePBS. So I wonder if I want to proceed with that, how can I what could be the best way for me to
good.
go on? Yeah.
So this will depend a lot on what language you feel more comfortable with and which client code you feel more comfortable with. We at Prysm, we already have a branch, and our client is written in Go, and we already have a branch, and we're already advanced in implementing this protocol. But other clients are already starting. Either they have a design doc or they have a plan on how to implement this. It's just that everyone is rushing through Electra. But as Electra time is being freed, people are looking more in depth into how to implement this. So my advice would be choose your language, choose your client that you feel more familiar with, and contact those CL devs and ask them. I know for a fact that Dustin from Nimbus is looking into this, Enrico from Teco is looking into this, Pawan from Lighthouse is looking into this, and Gajinder from Lodestar is looking into this. So I suspect that every client, if they don't have a branch yet, will soon start working on a proof of concept. I'm hoping more than suspecting, but I think this will happen. So if you just contact any of them, might actually just be very, very happy. Or if you contact us in our Discord, we already are running a branch. So I can point you to the branch where Prysm is having this implemented.
Great, thank you.
Amazing. Thank you so much, Potuz, for your time today and answering all sorts of questions here. We'll create a thread in the Protocol Fellowship channel in the R&D Discord server. If any of you guys have follow-up questions for Potuz or anything else around ePBS, we can post them in there. Yeah, thanks again, Potuz, for your time today and for giving us this walkthrough of ePBS. Yes.
Thank you so much. Yeah, we went a bit over time, but I think it was definitely worth it. And we all started a bit later, so it was really great. We learned a lot. Thank you so much, Potuz, for just the real important stuff, technical topic. Really enjoyed it. Learned a lot, man. Thanks a lot. And for everyone else, I wanted to say that I'll see you guys in Brussels, and otherwise next week we'll have the stand up, probably not the office hours as normal, and a week after the ETC we'll have office hours back for the project presentations. Not these sort of AMAs, but we'll have you guys to present the project. Yeah. Potuz, Terence, I'm not sure if you guys are coming to ETC. Probably not.
Terence is.
Terence is. Awesome. Yeah, so I hope to meet you there. I'll send you some details about our event there, so maybe you can meet some fellows if you have space. Yeah, awesome. Yeah, thank you so much, guys. I really appreciate